Hi friends, today we will explore the Shy Pie libraries of Python. So let's start the Shy Pie libraries. I have already made a file in the Jupyter notebook so that it will take less time to explain you. Okay. First, here we'll talk about the sampling, how to implement a coding in the sampling, random sampling, systematic sampling, and stratified sampling. So you need not to matter. Here, the important sampling process is random sampling that is used everywhere. Random sampling means a huge data set is there. Okay, from that data set, we are taking a sample of data to analyze that how this sample will predict. Is it predict the same as the huge data set, or the sample which we have taken is not good? Okay, so the random sampling is a process. Just we'll take a sample to investigate over that from the huge data set. Okay, so the first thing, the first and the very first thing in the scipy libraries is the p value is the important thing. So I will explain you the p value very soon. Okay, what is the importance of p value? Okay, and what are hypotheses? So step by step I will explain you. So today I will explain you the random sampling process and systematic sampling and stratified sampling, but we will have a deep explore over random sampling while implementing in a code. Okay, so this is the random sampling. So first from random import sample. Okay, this from the random library I've imported sample. Okay, so this is suppose the population 1. Okay, which contains a list of data from 1 to 10. Okay, from this we are taking a sample. We are taking a sample containing 3 data set. How we are taking sample 1 equal to sample, okay, population 1 comma 3. From the population we are taking 3 data set, so you can understand how to write this thing. Okay, so now sample 1 if you do it, now sample 1 if you do it, you may see here 8 10 2, 8 10 2 we have get sample 1 is 8 10 2. From this 8 10 2 we have selected. Okay, so this is the way of taking the random sampling. This whole program is the way to take the random sample from the huge population of 1 to 10. Okay, now this is now another is systematic sampling. In the systematic sampling, suppose we have a 10 data set, 1 to 10 data set, and we are picking the data after every two data set. Means we'll pick three, then after two data set 4 5, then 6 we'll pick, then after two data sets 7 8, then 9 we will pick. So like this, 3 6 9. So this is certain systematic way we are picking the data. Okay, so how to implement this type of sampling the coding, let's see. Okay, so in the systematic sampling, first of all, I have already taught you the NumPy libraries and Pandas libraries. Okay, so now here is no point of explaining NumPy and Pandas. Okay, I have just imported NumPy and Pandas. Okay, as NP and PD, and the total number of students which we are taking as 15. Okay, and the data is we are creating a dictionary like in terms of ID and height, like np dot arrange 1 comma number of students plus 1. So np dot arrange it will 1 comma 16 it will give 1 to 16, then 1 it is included and 16 it is not included, so total 15 data will be there and is converted into the list. Dot to list. Okay, you can take either like this or you can take either like this. Okay, this is little in advanced way I told, like this is the list. Okay, so ultimately we have to take the list. So np dot arrange, if we write 1 comma number of student 15 plus 1 it is 16. So 1 to 16 if we do, so it will give you the data from 1 to 15 only, 1 like 0 to total 15. Okay, so it will include 1 with index 0, it will include 2 with index 1. So like this, the 16 will be like at 15 indexes. Okay, the same here, if you see. So total here 1 to 16 numbers to 16. So total 15 data set will be there that we have to convert into list. Okay, that you have to keep remember. And then height we have taken total 15 heights. If you count here 159, 171 to total 164, it is total 15 heights. So now we are converting this like into the data frame. Okay, the PD while using pandas library pd dot data frame, this data we are converting into the data frame. See. Okay, so now here we see, here it is id height 1 159 1 2 170 1 2 3 158. So total, if you see here, total 15, total 15 is there. Okay, so number of students we have taken number of students plus one. So if you know, so I have already taught you np dot arrange 10 means it will give you 0 to 9. Np dot arrange 1 to 16 means it will give you 1 to 15. So here we have 15 data set total with its height. Okay, now once we have created it, now suppose we'll pick the data from this data, every three data, 3 5 9 9, like this will pick every three. After the third data will pick. So how to pick that one? See, systematic sampling, df comma steps, we are creating a function in terms of systematic sampling. Def systematic sampling df comma steps, indexes is equal to np dot arrange 0 comma len df comma steps equal to steps, print indexes systematic sample. ilock and lock I already have told you, using the use of ilock and lock. Okay, since we are working with the indexes, so we'll use ilock, then return systematic sample. So this function you just need to explore. I already told you over here, this is the way to create a systematic sampling. Now once this function is created, we may read this systematic sampling function in with inside the variable systematic sample, like df comma 3. Df is the my this data. From this data we'll take a third data, like 0 1 2 3 we will take. Okay, got the thing? So you may see here the after everything 0 3 6 9 12. Okay, we start with 0, then 1 2 we leave, then 3, then 4 5 we leave, then 6, then 7 8 we leave, then 9, then 10 11 we leave, then 12. Okay, now if we see inside the data frame this thing, you may uh see here 0 3 6 9 12. Okay, got the thing? I think now it is clear to you the systematic sampling in a systematic way we are picking the data, and how to write inside the code that now you have learnt with me. First create this function of systematic sampling. Okay, like steps, actually steps means after what data, steps is equal to 3 means a third data, from initial to third data will pick. Df, we have already the 0 to len df we have created, arrange and steps equal to step, then print indexes, then systematic sample with that indexes, it will locate the data with that indexes. Okay, so now it is clear, you just need to see and practice, you will get it. Okay, the main thing is that systematic sampling. Okay, now here stratified sampling. The stratified sampling is like, if you see here, name Lisa, Kate, Ben, Kim, Josh, Alex, Evan, Greg, Sam, Ella. I have created a dictionary with the inside the name, a list of name is this one. Inside the ID, the list of this one. Inside the grade, we are listed as A, C, B, A, category 231321. So if we put in the data frames, DFPD data frame, we'll get like this: name, ID, grade A. So if you have gone through my SQL lecture, then here a stratified sampling, we can suppose we will make a sample according to the male wise, according to the grade wise, like this we have to make it. Okay, so here I think we can use a group by command. Group by is categorizing the thing together. Okay, so group by grade, df is the data, this thing, dot group by grade, group key is equal to false, apply lambda x colon x sample 2. Okay, x sample 2. So this is a group by command I have applied over it. So you will get it. See, so only the grade we have used here. Okay, you can see by we have categorized according to the grade. Okay, so A, B, C, first AA, then BB, then CC. Okay, so now the question is first AA, then BB, then CC. Okay, so we are taking from each group two datas. We are taking from categorizing by grade terms, and we are taking only two data. We are taking only how much data? Two data, like because there is 3A, but here we have 2A, 2B, 2C. Okay, got the thing. So now another thing, if we explore here, see here, if we explore now, this is not the full data set. If you see, like if you see here, like just see here. So we are categorizing the data by grade wise. Okay, so we have categorized like this. Okay, now another way is to categorize it like this. See, grade group keys apply lambda x sample fraction equal to zero point 0.6. Earlier it was 2. Now here it is 0.6. So it will create a ratio of 3 is to 2 is to 1. Like here I've written A is total 5. So 5 total A inside this data set, total A inside this data set is 5. 1, 2, 3, 4, 5. Okay. And total B is 3, total C is 2. So 5 is to 3 is to 2. Okay, so now here if we write here, like obviously we are categorizing the data by grade. Now here if we write the 2, 2. Okay, so here we are writing the 2. So it means it will take the sample 2, 2, 2. From each data it will take the sample 2, 2, 2. But if we take like this, a fraction, x dot sample fraction is equal to 6.6, then it will take A is equal to 5, then by due to this point 6, 5.6 equal to 3, total 3A will be present, then 3 into point 0.6, 1.8, so it will take as a 2. So total 2B is present, then 2 comma zero point 0.6, 2 into point 0.6 will be 1.2, so total 1 will be present, C will be 1. Okay, so I think now stratified is thing. So this you just have to see, but the main thing is the random sampling over here. Random sampling over here. Okay, so this is the random sampling. You need to know about this. I hope you understand this thing, the random sampling thing. Okay, so how to take a create a population in the list and then take us how to take a sample of 3 from that population. So like this, you need to know this. Okay, then we'll explore more in the next lecture. Okay, then.